Reversing the polarity on a motor has different effects depending on the type of motor and how the reversal is done. For a motor running off 220 volts, if one hot wire remains correctly wired, the motor will still operate, but it may experience reduced power or overheating due to incorrect phase matching. The motor will not run in reverse in this scenario. However, the motor will run in reverse if both hot wires are reversed. This is because alternating current reverses its polarity several times per second, and by reversing the wires, the direction of the magnetic field that drives the motor is also reversed. Now let's consider appliances plugged into a receptacle. Most appliances are not polarity sensitive and will not be affected by a reversed hot and neutral. However, some appliances, such as refrigerators and air conditioners, may run inefficiently or even malfunction if the polarity is reversed. If a single appliance is plugged into a receptacle with reversed polarity, it may exhibit abnormal behavior. For example, a vacuum cleaner might experience reduced suction or overheating. A garbage disposal may not rotate or may run in the wrong direction. In general, it is not recommended to reverse the polarity of electrical connections. Reversing polarity can lead to unsafe conditions, equipment damage, or improper operation. Always refer to the manufacturer's instructions and follow proper electrical codes when working with electrical equipment. Now let's delve deeper into the technical aspects. Alternating current, or AC, is characterized by its constantly changing polarity. In the United States, the standard AC frequency is 60 Hz, meaning the polarity reverses 60 times per second. Motors designed to run on AC utilize this alternating current to create a rotating magnetic field within the motor. This rotating magnetic field interacts with the magnetic field of the rotor, causing it to spin. When you reverse both hot wires on a 220 volts motor, you are essentially reversing the direction of the rotating magnetic field. This, in turn, causes the rotor to spin in the opposite direction. However, when only one hot wire is reversed, the motor's performance becomes unpredictable. The motor may still run because it is still receiving power, but the incorrect phase matching can lead to inefficiencies and potentially damage the motor. The reduced power output occurs because the magnetic fields are not interacting as efficiently as they should. The overheating can result from the increased current draw as the motor struggles to operate under these suboptimal conditions. Now let's shift our focus to appliances and receptacles. Electrical codes specify that receptacles should be wired with the hot wire connected to the smaller slot and the neutral wire connected to the larger slot. This is done to ensure that appliances are wired correctly and that safety features, such as fuses and circuit breakers, function as intended. When the hot and neutral wires are reversed, the appliance may still operate, but the safety features may not work properly. For example, the appliance's fuse may not blow if there is a fault, potentially leading to a fire hazard. Some appliances are more sensitive to reverse polarity than others. Appliances with electronic components such as refrigerators, air conditioners, and computers are more likely to be affected by reverse polarity. These appliances rely on precise voltage levels and polarity to operate correctly. When the polarity is reversed, these appliances may malfunction or even be damaged. A vacuum cleaner with reversed polarity may experience reduced suction because the motor is not running at its optimal speed. Additionally, the motor may overheat due to the increased current draw. A garbage disposal with reversed polarity may not rotate or may run in the wrong direction because the motor is not receiving the correct polarity signal. This can damage the disposal and potentially create a safety hazard. It is important to note that electrical codes vary from place to place. Always consult the local electrical codes and regulations when working with electrical equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Now let's consider some additional safety precautions. Always turn off the power at the circuit breaker before working on any electrical equipment. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment, such as gloves and safety glasses. Never work on electrical equipment when you are wet or standing in water. If you are unsure about anything, consult a qualified electrician. When troubleshooting electrical problems, start by checking the circuit breaker. Make sure that the breaker is not tripped. If the breaker is tripped, reset it. If the breaker trips again, there is likely a short circuit or other electrical problem. Next, check the receptacle. Use a voltage tester to verify that the receptacle is wired correctly. If the receptacle is wired incorrectly, correct the wiring. Finally, check the appliance. Make sure that the appliance is plugged in properly and that all of the connections are secure. If the appliance is still not working, it may need to be repaired or replaced. Understanding the principles of electricity and electrical safety is essential for anyone who works with electrical equipment. By following the safety precautions outlined above, you can minimize the risk of electrical shock and other electrical hazards. Furthermore, reversing polarity can also affect the performance and lifespan of electrical components. Electronic devices, in particular, are designed to operate with specific polarity. Reversed polarity can cause these components to overheat, fail prematurely, or even be damaged beyond repair. For instance, consider a simple diode. Diodes are semiconductor devices that allow current to flow in only one direction. If a diode is connected with reversed polarity, it will block the flow of current and may overheat and fail. Similarly, capacitors are electrical components that store energy. Electrolytic capacitors are polarized, meaning they have a positive and negative terminal. If an electrolytic capacitor is connected with reverse polarity, it can explode. In industrial settings, incorrect polarity can have even more serious consequences. Motors, generators, and other electrical equipment are often connected to complex control systems. Reverse polarity can disrupt the operation of these systems, leading to equipment damage, production downtime, and even safety hazards. For example, a three-phase motor connected with incorrect polarity may run backward or overheat, potentially causing damage to the motor and equipment it is driving. To prevent polarity reversal, it is essential to follow proper wiring procedures and use appropriate testing equipment. Before connecting any electrical equipment, always verify the polarity of the power source and the equipment. Use a voltage tester or polarity tester to confirm that the hot, neutral, and ground wires are connected correctly. When working with polarized components such as diodes and electrolytic capacitors, always pay close attention to the polarity markings. Ensure that the positive and negative terminals are connected to the correct points in the circuit. In addition to proper wiring and testing, regular maintenance is also important. Inspect electrical connections periodically for signs of corrosion or damage. Replace any damaged wires or components immediately. Ensure that all electrical equipment is properly grounded. Grounding provides a path for fault current to flow to ground, protecting people and equipment from electrical shock. When working with high voltage equipment, always follow lockout/tagout procedures. Lockout/tagout procedures ensure that the equipment is de-energized and cannot be accidentally energized while work is being performed. In summary, reversing polarity can have a variety of negative effects on electrical equipment and systems. It can cause reduced performance, overheating, component failure, equipment damage, and safety hazards. To prevent polarity reversal, follow proper wiring procedures, use appropriate testing equipment, and perform regular maintenance. When working with electrical equipment, always prioritize safety and follow all applicable codes and regulations. Now let's discuss the NEC, or National Electrical Code, and its relevance to polarity. The NEC provides guidelines for safe electrical installations. Section 200.10b of the NEC requires that the grounded conductor, which is typically the neutral wire, be identified by a continuous white or grey color. This requirement helps to ensure that the grounded conductor is easily distinguishable from the ungrounded conductors, which are typically black or red. Section 200.11 of the NEC requires that the terminals of electrical devices, such as receptacles and switches, be identified for proper polarity. The terminal for the grounded conductor must be identified by a white or grey marking, while the terminal for the ungrounded conductor must be identified by a brass-colored marking. These requirements help to ensure that electrical devices are wired correctly and that polarity is maintained throughout the electrical system. Section 406.3e of the NEC prohibits the reversal of polarity in receptacles. This means that the hot wire must be connected to the smaller slot and the neutral wire must be connected to the larger slot. This requirement helps to prevent electrical shock and other electrical hazards. Section 514.11 of the NEC requires that all electrical equipment in gasoline dispensing and service stations be installed in accordance with the manufacturer's instructions and be listed for use in hazardous locations. This requirement helps to prevent fires and explosions in these potentially dangerous environments. It's also important to discuss grounding and bonding. Grounding is the process of connecting electrical equipment to the earth. This provides a path for fault current to flow to ground, protecting people and equipment from electrical shock. Bonding is the process of connecting different metal parts of an electrical system together. This helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electrical shock. Section 250.4a of the NEC requires that all electrical systems be grounded in accordance with the requirements of Article 250. This section also specifies the methods for grounding different types of electrical systems. Section 250.92 of the NEC requires that all metal enclosures containing electrical conductors be bonded together. This section also specifies the methods for bonding different types of metal enclosures. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. For example, the National Fire Protection Association, or NFPA, publishes a number of standards related to electrical safety, including NFPA 70E, Standard for Electrical Safety in the Workplace. This standard provides guidance on safe work practices for electrical workers. The Occupational Safety and Health Administration, or OSHA, also has regulations related to electrical safety. These regulations require employers to provide a safe workplace for their employees and to comply with all applicable electrical codes and standards. In conclusion, polarity is an important consideration in electrical installations. Reversing polarity can have a variety of negative effects on electrical equipment and systems. To prevent polarity reversal, follow proper wiring procedures, use appropriate testing equipment, and perform regular maintenance. When working with electrical equipment, always prioritize safety and follow all applicable codes and regulations, including the NEC, NFPA standards, and OSHA regulations.